In this video, we're going to explore the concepts of authentication and authorization, and how they are used to control access to database objects. We will also discuss security measures. Authentication is represented by a lock icon and confirms your identity. Authorization is represented by a check mark icon and determines what you can access. Security is represented by a shield icon and protects the data. Authentication is the process of verifying who a user is. It confirms a user's identity through credentials, typically a username and password. Authentication is the first step in the security process. Authorization, on the other hand, determines what an authenticated user can access. It grants specific permissions to resources based on user roles and privileges. Authorization occurs after successful authentication. There are several methods to authenticate users in a database. Password authentication is the most common method, where users provide a username and password to verify their identity. An example of creating a user with password authentication is shown here. Certificate-based authentication uses digital certificates to authenticate users, providing stronger security than passwords alone. An example of creating a user with certificate-based authentication is shown here. Multi-factor authentication requires multiple forms of verification before granting access to database resources. This is often implemented at the application level. External authentication delegates authentication to external systems like Lightweight Directory Access Protocol, Active Directory, or Kerberos. An example of creating a user with external authentication is shown here. Authorization in databases relies on several key concepts. Privileges are specific permissions granted to users that control operations like select, insert, update, and delete. These can be assigned at various levels such as table or column. Roles are collections of privileges grouped together to simplify privilege management. Users can be assigned to multiple roles, enabling role-based access control. There are different access control models such as discretionary access control, role-based access control, mandatory access control, and attribute-based access control. The principle of least privilege is a core security practice where users are granted only the permissions needed for their tasks, minimizing potential damage from security breaches and reducing the attack surface. There are several common database privileges. Data privileges control access to data manipulation operations. These include select, insert, update, delete, references, and execute. The code example shows granting select and insert privileges on the employees table to the HR staff. Administrative privileges control access to database administration operations. These include create, alter, drop, index, create view, and grant option. The code example shows granting create table and create view privileges to the database developer. Privileges can be assigned at different levels, including global, database, table, column, procedure, and function. The code example shows granting update privileges on the salary and bonus columns of the employees table to the payroll administrator. It's also important to know how to revoke privileges. The code example shows how to remove specific privileges such as insert and update on the employees table from a temporary user, as well as how to remove all privileges on the employees table from an inactive user. Role-based access control, or RBAC, is a security approach that restricts system access based on roles. It simplifies privilege management by grouping permissions, and users are assigned to roles rather than individual permissions, which reduces administrative overhead and security risks. There are benefits of role-based access control: simplified administration, improved security compliance, reduced privilege creep, and easier auditing and reporting. The code example shows role-based access control implementation where read-only role is created. Read-write role is also created. Lastly, admin role is created. Further privileges are assigned to roles. Grant select on all tables to read-only role. Grant select, insert, update, delete on all tables to read-write role. Roles are assigned to users. Grant read-only role to analyst user. Grant read-write role to developer user. Grant admin role to database administrator user. Roles can inherit permissions from other roles, creating a hierarchical structure of privileges. Row-level security restricts which rows a user can access in a database table based on their identity or role. For example, user A sees rows 1 to 50, and user B sees rows 51 to 100. The Postgres structured query language, row-level security example shows creating a table named employees. Then create policy for department managers. Column-level security restricts access to specific columns in a table, allowing users to see only certain fields. For example, Human Resources sees ID, name, department, salary. Staff sees ID, name, department but does not see salary. Code example of column-level privileges includes grant select including ID, name, department on employees to staff role. Grant select including ID, name, department and salary on employees to HR role. Using views for column-level security. Create view staff employees as select ID, name, department from employees. To ensure database security, it's important to follow best practices. For authentication, implement strong password policies, use multi-factor authentication when possible, regularly rotate credentials, avoid shared accounts, and implement account lockout policies. For authorization, apply the principle of least privilege, implement role-based access control, regularly review and audit permissions, revoke unnecessary privileges, and use row or column-level security when needed. For data protection, encrypt sensitive data at rest, use transport layer security or secure sockets layer for data in transit, implement data masking for sensitive fields, consider transparent data encryption, and protect backup files with encryption. For auditing, enable comprehensive audit logging, monitor privileged user activities, track schema changes, implement alerts for suspicious activities, and regularly review audit logs. For vulnerability management, keep database software updated, apply security patches promptly, conduct regular security assessments, test for structured query language injection vulnerabilities, and remove unnecessary features and services. For operational security, document security policies and procedures, train staff on security best practices, implement change management processes, create and test disaster recovery plans, and segment database networks. Let's summarize the key takeaways from this video. Authentication verifies user identity before granting access, and uses multiple methods such as passwords, certificates, and external systems. Multi-factor authentication enhances security and is the first step in the security process. Authorization controls what authenticated users can access and is based on privileges, roles, and access control models. It implements the principle of least privilege and can be applied at various levels like row or column. Role-based access control simplifies privilege management by grouping permissions into roles. Users are assigned to roles rather than individual permissions, and it supports hierarchical privilege structures. Some security best practices are implementing strong authentication mechanisms, applying the principle of least privilege, regularly auditing and reviewing permissions, and encrypting sensitive data at rest and in transit. As Bruce Schneier said, security is not a product but a process. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.